everyone, it's Justin again. In the previous lesson, you learned how to calculate the slope of a line when it's on a graph. We were able to count to find the change in y, and count to find the change in x. Write them as a fraction, and reduce if possible. But what if this visual isn't given to us, and all we have is the coordinates of 2 points from the line? How will we calculate the slope without seeing it on a coordinate plane? Or what if some points from the line are given to us in a table instead? How do we calculate the slope from this? This is exactly what we're going to learn about today. I'm also going to complete one example problem with you, and my good friend Jenna will help us finish a second example problem. Here's the type of problem you would have seen in the previous lesson. It says to calculate the slope of the line, which we know to be the change in y over the change in x. If we start at the point further to the left and use arrows and count to the next point, we can see that this y value changed by positive 3 units and the x value changed by positive 6 units. But could we have gotten those same numbers for the change in y and change in x by using the values in these coordinates? What operation could we use with the numbers 6 and 3 to figure out that the y value changed by 3 units? How could 6 and 3 give us an answer of 3? Yep, we can subtract. And more specifically, we can subtract the y value of the point we started at, which is 3, from the y value of the point we ended at, which is 6. Now, does this work with x values as well? Our change in x is 6, but how can we get 6 by using the x values of the coordinates? We would take the x value of the point we're ending at and subtract the x value of the point we're starting at. Then we simplify like normal. Now, you may really like this description and prefer to think of it this way when you're doing your calculations, but I want to give you another option so you can decide which one you like better. We can also label the point we start at as x1, y1, and the point we end at as x2, y2. Then we can shorten our descriptions by using these labels instead. This gives us another way to think about the slope of the line. If you really like this new option, that's great, but don't forget what it conceptually means. To calculate the change between 2 points, we could take the ending value and subtract the starting value. Now that we have this new formula, I want to go back to that example we were looking at a moment ago. I know we already figured out the answer to this, but I want you to try something for me. Remember how I explained in the previous lesson that you can go in either direction when calculating slope? This means our starting and ending points can switch, and we'll still get the same answer. So take a moment to use this new way of calculating the slope and show that we still get the same answer even when we use different starting and ending points. Pause the video now so you can calculate this yourself. y2 minus y1 is 3 minus 6, and x2 minus x1 is 1 minus 7. Then we can simplify this. 3 minus 6 is negative 3, and 1 minus 7 is negative 6. A negative number divided by another negative number gives a positive number. And dividing the numerator and denominator by their greatest common factor gives us 1/2 again, just like we got earlier in this video. Now that we understand how to calculate the slope using 2 points from a line, let's try out 2 example problems. This problem says to calculate the slope of the line containing the points -4, 5 and 6, -1. You may be thinking that you could just plot these points on a graph and count the change in y and change in x like you learned in the previous lesson, and you totally could. But the numbers in our coordinates won't always be this nice. So for this problem, be sure to use the concept we just talked about to do your calculations. Pause the video now and calculate the slope on your own. We're going to go over both ways to substitute the values in so you can check your work. The first way we'll go over is if you decided to use -4, 5 as your starting point, and 6, -1 as your ending point. Then your work should look like this. The most common mistake people make when calculating slope is messing up a negative or subtraction sign. This denominator says 6 minus negative 4. Notice here that this subtraction sign was written because it was part of our original formula. And this negative sign is here because it's part of the number we're subtracting. Then we can simplify. Negative 1 minus 5 is negative 6, and 6 minus negative 4 is the same as 6 plus 4, which is 10. Dividing by the greatest common factor of negative 6 and 10 gives us negative 3/5. Remember, it's proper math grammar to have the negative sign for a fraction either in the numerator or out front of the fraction. So what we have here is fine, or we can move the negative sign out front. Either is considered acceptable. If you chose to label your points the other way around, then your way works great too. Let's go over that option now. Substituting these values in will still bring us to the same answer. Either way you choose to have your starting point and ending point is fine. And remember that if you don't want to think of this slope formula as y2 minus y1 over x2 minus x1, you don't have to. You can think of it as ending y value minus starting y value over the ending x value minus the starting x value. Here's one more example to complete. The directions say to calculate the slope of the line containing the points shown in the table. This table has two columns, an x column and a y column. Tables can be used to write many points in an organized way. This is telling us 4 points that are on the line. Negative 2, comma negative 15 is a point on the line, along with negative 1, comma negative 12, and 1, comma negative 6, and 3, comma 0. We only need 2 of these points to calculate the slope, so we can really choose any 2 points and label them as x1, y1 and x2, y2. The points you choose may depend on which numbers you find easier to work with, but in order for you to be able to check your work with mine, go ahead and use negative 2, comma negative 15 as the starting point and 3, comma 0 as the ending point for this problem. Pause the video here and try to calculate the slope now. All right, to make sure you have the right answer, my good friend Jenna is going to step in here and work this out for you by hand. Take it away, Jenna.
Thanks, Justin. Hey there, it's me, Jenna. I'm going to show you the work for this problem and also how I like to check my work in my head to make sure I didn't make any silly mistakes. First, I like to draw my fraction bar and then a minus sign in the numerator and denominator. Then I like to change the color I'm writing with and substitute in y2, y1, x2, and x1. This helps me make sure I don't mess up in a place like this where I have a minus and a negative right next to each other. I like to cross out the minus and negative and change it to a plus, since subtracting a negative is the same as adding. I simplify the numerator and denominator next, and then I like to stop and check my work. I like to picture a number line in my head and think about how I'd have to move when going from my starting point to my ending point. I'm going to write it down for you just so you can see what I'm thinking. Going from negative 15 to 0 would require me to move 15 units in the positive direction, which is exactly what I got for the numerator. And moving from negative 2 to positive 3 would require me to go 5 units in the positive direction, which is exactly what I ended up with for the denominator. Visualizing moving on a number line is just something I like to do to make sure my answer is correct so far. I can also draw arrows on the table to represent these same changes. That's another thing you can do to help make sure your work makes sense. Then all that's left is to simplify, if we need to. It looks like I can divide both 15 and 5 by 5, which leaves me with 3 over 1 as the slope. And it's really unnecessary to write a 1 in the denominator, so I can just write the slope as positive 3. And there we have it. Thanks for following along with me. I'm going to send you back over to Justin. Hey, Justin, don't forget we have a pickleball game tonight. I'll meet you there.
Thanks, Jenna. And yes, I'll be there. Anyways, I hope you're getting comfortable calculating slope when you have 2 points or a table of points. I also hope that Jenna's handwritten work and the logic she uses to check her work was able to help bring that process to life for you. Remember that we have a formula to calculate the slope when we don't have the line in front of us on a graph. But this formula still means the change in y over the change in x, also known as the rise over run. And don't forget that you can still check if your answer seems reasonable using the direction and steepness concept we learned earlier. Even though the points aren't given to you on a graph, you can still estimate where they would be on a graph, or even picture this in your head to make sure the direction and steepness of your slope do seem reasonable. Now that you've completed the video and guided notes, there's a short bonus activity in your PDF to complete before your practice game. See you next time!